Why engineers are baffled by these ancient rock churches. This is not a building. It's a sculpture. A church, nearly 40 feet tall, carved from a single piece of solid rock. It's one of 11 ancient churches in Ethiopia. Modern engineers are fascinated because these churches weren't built in the traditional way. Instead, they were carved downward into solid rock. Of the 11 churches, 4 are completely freestanding. The others are carved directly into the surrounding rock. There are no bricks, no mortar, and no construction joints. So how on earth did they do it? For engineers and architects, the rock-hewn churches of Lalibela are one of history's most stunning achievements. How did medieval builders, with simple hand tools, pull off a feat that still leaves experts in awe? The Visionary and the New Jerusalem. The story begins in the 12th century, with a legendary ruler, King Gebre Meskel Lalibela. According to Ethiopian tradition, the king had a powerful vision. After the historic city of Jerusalem was captured the year 1187, Christian pilgrimages to the Holy Land became incredibly dangerous. King Lalibela's ambitious solution was to build a new Jerusalem right in the heart of his kingdom. He chose a remote town in the Ethiopian Highlands, then called Roha, sitting at an altitude of roughly 8,200 to 8,600 feet. This was his canvas. The new holy city was a symbolic replica of the original. The local stream was named the Jordanos, or Jordan River, and the tomb of King Lalibela himself is housed in a church called Biete Golgotha Mikael. The vision was clear: to recreate the Holy Land, not by building, but by shaping the very earth itself. Deconstructing the puzzle, the monolithic method. So, how do you build a church by starting with the roof? This is the first engineering puzzle of Lalibela. The builders used a mind-bending technique that architects call subtractive architecture, or top-down construction. Picture a mountain of solid, reddish volcanic rock. Instead of hauling stones to a site, thousands of workers first dug massive trenches, some over 40 feet deep, straight into the bedrock. They chiseled down, tracing the church's perimeter to isolate a giant, freestanding block of stone in the middle. That massive block was the church. Only after the exterior was freed did they begin the even harder part, hollowing it out. Carving from the top down, they sculpted doors, windows, columns, and arches, all from that single piece of stone. At first glance, this method seems to make construction far more difficult than building with separate stone blocks. So why would medieval builders choose it? The answer lies in the rock itself. Once the outer trenches were cut, there was no need for massive scaffolding, and gravity helped remove much of the excavated stone. But it's also completely unforgiving. Every single cut was permanent. You couldn't just patch a mistake with mortar. The entire building, from its vaulted ceilings to its floors, had to be visualized in 3 dimensions before the first chisel ever struck rock. Deconstructing the puzzle, impossible precision. That brings us to the next point of fascination: the precision. The churches of Lalibela aren't crude caves. They are sophisticated works of architecture. You find graceful arches, detailed window carvings, and towering pillars that imitate traditional built structures. Even though, being solid rock, they don't actually need columns for support. Archaeologists believe the workers used simple tools: hammers, chisels, and axes. With these basic implements, the craftsmen achieved stunning consistency. They even skillfully replicated architectural details from the ancient Aksumite Empire, which had flourished centuries earlier. The Biete Emmanuel Church, for instance, brilliantly mimics the Aksumite style of layering wood and stone, except it's all carved from a single rock. How could workers maintain such perfect lines and proportions while carving downwards, often in semi-darkness? The level of planning and geometric accuracy required is staggering. Deconstructing the puzzle, advanced water management. Carving a city of deep pits in a highland region known for heavy seasonal rains creates an obvious, potentially catastrophic problem: flooding. And this is where Lalibela's engineering genius really shines. The builders didn't just carve churches. They also engineered an advanced water management system. It protected the churches from flooding and collected valuable rainwater. To stop the sunken courtyards from turning into giant swimming pools, they carved an extensive network of drainage ditches, tunnels, and canals. The roofs of the churches themselves were sloped to channel rainwater away, and gutters were chiseled along the edges, leading to channels that whisked water away from the foundations. But this wasn't just about getting rid of water. The system also fed baptismal pools and cisterns, harvesting a precious resource in a dry region. It was a fully integrated hydroengineering system, designed both to protect the structures and sustain the community, and parts of it still function today. Deconstructing the puzzle, the logistical nightmare. Finally, there's the sheer scale of the operation. Some modern estimates suggest that a workforce of up to 40,000 people might have been needed to pull this off. Think about the logistics of feeding, housing, and organizing tens of thousands of workers in a remote, mountainous area. And what happened to all the rubble? Excavating these churches produced an immense amount of stone, and for a long time, the lack of giant spoil heaps was a baffling question. While archaeologists have now identified areas where this material was deposited, the pure logistical challenge of moving it all remains a topic of research. Local tradition, of course, has a simpler explanation for the project's speed and scale. Human workers toiled by day, and at night, angels descended from heaven to continue the construction at double the pace. This legend highlights just how unbelievable the accomplishment seemed, even centuries ago. While tradition holds that the 11 churches were completed within King Lalibela's 24-year reign, some scholars now argue the construction may have spanned several centuries, possibly starting as early as the 7th century and evolving over time. This debate among experts only deepens the site's fascination. The churches of Lalibela are a UNESCO World Heritage Site and have been a living, breathing center of pilgrimage and worship for more than 800 years. It's a place where faith and engineering are literally carved into the bones of the earth. Today, this incredible heritage faces threats from erosion and nearby development, prompting ongoing preservation efforts to protect it. If you're fascinated by how ancient ingenuity continues to inspire the world, consider subscribing for more stories that unearth these incredible achievements. So why do engineers and architects marvel at Lalibela? Because it turns the conventional rules of construction on their head. It's architecture created through removal, not addition. The builders had to be masters of geology, hydrology, and structural engineering, all without the aid of modern science. They had to think in reverse, carving a finished cathedral out of a solid block of stone where a single miscalculation could have been catastrophic. Lalibela is more than a collection of stunning monuments. It's a testament to a different way of thinking, where logistics, water management, and structural design were all solved in one integrated, brilliant plan. Whether it was the work of a single visionary king, generations of master craftsmen, or, as the legends say, angels, the result is the same: a sacred city that doesn't seem to be built on the earth, but born from within it. It leaves us with a lingering question. If this is what was possible with simple hand tools over 800 years ago, what other masterpieces of human ingenuity are still out there, waiting to be uncovered?